Hi everyone, welcome back to the channel. In this video, I'm going to walk you through the quantum resource health wall. It's a dashboard concept I designed to help make hybrid quantum classical operations easier to monitor, understand, and act on. The goal here is simple. Instead of jumping between logs, backend consoles, job pages, and calibration data, this dashboard brings the most important information into one place. So you can quickly understand the health of each backend and decide on what to do next. I'll show you how the wall is organized, what each tile means, and how the detail panels help you go from high-level overview to a more specific operational view. So let's start with the dashboard overview. At the top, you'll see the title of the dashboard and then a set of filters for backend types, organization, and workload. These filters are meant to help operators narrow the view fast. So if someone only wants to see QPUs or only simulators or only a specific workload type like VQE or QAOA, they can do that without losing the overall structure of the dashboard. On the right side, you can see that there's also a health status legend, a time range selector, and a system overview panel. That gives you a quick summary of how many backends are healthy, under watch, or in critical state. So the structure of the dashboard is basically as follows. Each tile on the wall represents one backend. So at a glance, the tile shows backend name, the number of qubits that are on the backend, or whether it's a simulator. You can also see a health indicator in the center, a primary health metric like coherence, uptime, or availability. Then there are two small gauges for jobs and queue, two trend lines for errors and calibration activity, and finally, a button that takes you into the details view. The idea is that a user can scan the wall very quickly and immediately know which backends are performing well and which ones are under pressure, and also which ones need attention, like, for example, this one here, the IonQ Forte. So let's talk about the health indicator. The traffic style or the traffic light style indicator is really the core visual signal here. The green means that the backend is in good shape. Yellow means it's showing some drift or pressure and should be watched. And red means it's in critical condition and may need intervention or rerouting. This color system is meant to be simple and familiar because in high pressure operational environment, the user shouldn't have to decode the dashboard before they can respond. So if we look at the job and queue gauges below the health indicator, you'll see the job and queue gauges. The jobs gauge shows how much of the backend is currently occupied by active or pending work. The queue gauge shows how much waiting pressure exists before jobs can start. So together, these two gauges help answer a very quick or very important question. Is the backend healthy but simply busy, or is it actually becoming congested? That distinction matters because a backend can still be technically healthy while being overloaded. So if next below that are the trend lines. So at the bottom of each tile, we have these trend lines. There are two trend lines. One shows the error over time, or the errors over time, and the other shows calibration activity. The error trend line helps you see whether the backend is becoming more stable or less stable over the selected time window, which is what the time is selected in the time range widget right here. And the calibration trend line gives context for that movement by showing whether the backend has recently been recalibrated or is changing more frequently than usual. So instead of just seeing a single snapshot, you get a sense of motion. So you can tell if the backend is improving, degrading, or fluctuating. So let's look at the detail panel next. So when you click a tile, as so. You can see the dashboard opens a detail panel that gives a much deeper view of that backend. So this is where the dashboard moves from summary to diagnosis. Inside the detail panel, you can see KPI cards for the backend's current condition, a timeline for error rates, a breakdown of job types currently using that backend, a qubit health map for each QPU or for the QPUs, an active jobs table, a calibration log, and when needed, if I close this details section here and open this one, when it's needed, you'll see a reroute alert for critical conditions. And this is important because a dashboard like this shouldn't just tell you something is wrong, it should help you understand what exactly is happening. So let's look at this dashboard in more detail. The KPI cards at the top are designed to make the most important operational values immediately visible. So these include coherence, readout errors, active jobs, and T1, T2 time. So each card gives a current plus a small trend indicator. So the user can quickly see whether the metric is improving or getting worse, as you can see in these indicators right there. This helps to connect the big picture or the big health score to the more specific technical metrics behind it. In the error timeline, you can see basically it shows how the error rates change over time. And this is useful because a single number doesn't tell the whole story. You want to know if the backend has been stable for the last hour, if errors are rising, or if there was a spike around a calibration event. So this chart helps operators connect events to performance changes. The job distribution widget or donut basically shows what types of jobs are currently running on the backend. For example, it may show a mix of VQE, QAOA, Grover, or other workloads. And that matters because different workloads can stress the backend in different ways, and understanding the mix helps planning, debugging, and performance analysis. The qubit health map basically it's for actual QPUs. So this gives a per qubit view of which qubits are healthy, which ones are degraded, and which ones have failed. And that's especially useful when operators need to understand whether a problem is isolated to a few qubits or whether the backend is experiencing a broader issue. Below the health map is the active jobs table. So the table basically shows the backend's current workload in more detail. So for each job, you'll see the job ID, the algorithm type, the number of shots, the status, the runtime, and the error rate. So this makes the dashboard much more useful for operational follow-up because the user can immediately connect backend health to specific jobs that are currently running or waiting. Next is the calibration log. The calibration logs gives a timeline of important backend events. So basically it might show things like a full recalibration, a coherence degradation warning, a gate error spike, a routine calibration check, or a temperature-related issue. This section is especially useful because it provides context. If a backend is underperforming, the log can help explain why. So I will go back up to the top here and to talk about this critical backend status and the auto reroute jobs button. So when a backend enters a critical state, the dashboard can surface a strong alert and suggest rerouting jobs elsewhere. This is one of the most important parts of the concept because the dashboard is not just descriptive, it's operational. Reroute actions should be treated carefully, however. It should only move jobs to compatible backends when the job requirements, qubit count, gate set, and execution constraints make that safe to do so. So the reroute should support fast action, but also preserve confidence and control. We don't want to reroute jobs and to a different backend, for example, and cause even more errors or even more a worse situation that we currently have. So overall, the quantum resource health wall is about making hybrid quantum classical operators easier to understand at a glance and easier to act on when something goes wrong. It combines health monitoring, job telemetry, calibration context, and reroute support into one coherent system. And the goal is to reduce complexity without hiding the detail that operators actually need. So that's the quantum resource health wall. If you liked the dashboard, please like the video and subscribe and comment below. Let me know what you thought of the dashboard, if there's any features that you're wondering or curious about, or features that you would add. I would love to hear your feedback. Thank you, and see you in the next video.